Hey guys, welcome back to my second video. Today I'm going to be taking on LeetCode 187, repeated DNA sequences. So essentially, the description for this is given a string S that represents a DNA sequence, return all the 10-letter long sequences or substrings that occur more than once in a DNA molecule. You may return the answer in any order, and they are explicitly with A's, C's, G's, and T's. So essentially, you have to go through each string and look at the first 10, for instance, and then that would be like a window that you look at. So the method that you probably use here is a sliding window. Considering that it is a sequence problem, you're looking for a sequence of letters, it's almost obvious that is like an indication that you need to use a sliding window. So what you want to do is you want to go through and find, say this is one substring, and then slowly move down, and then eventually you find this one too, and then you realize that these were the same, those two were the same, and then you add it to some sort of result, and then you print that result, and you do the same thing, I believe, for this one and this one. Those are the same, so you take it and you add it to that result, the list of strings, and you print that. Then here, so there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's one there, but realistically there should be one from here to here, and then one from here to here, and here to here. So you might expect 4, but there's only one. So I presume an important part is to make sure that the result has no duplicates either. That's probably very important. So what I'm going to do is I'm going to start saying, okay, so first we obviously need some sort of result. All right. And then what we need is, when say we're looking through this, how I can go about displaying the sliding window is I can say, like, for instance, let's say we have our current window, and we can say S for the string, and then in square brackets we can say the indices of the start and the end that we don't include in the string. So for instance, if we have 0 and then colon and 10, it's going to show 0, and then it's going to show all the numbers, the characters from 0 to 9, so that's not including 10. So that would be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's perfect. That's all we need, right? So like if I try to return current window, it should return what I just highlighted down here. Yeah, that's 10 long, which is exactly what we need. Okay, so that's how I'm gonna like set a value to the current window that we're at. But instead of using numbers, I'm gonna use variables that we slowly increment until we're all the way across. So for instance, I'm gonna start here and I'm gonna look at these. Okay, and basically to check if I've already seen this, or let's say I get to this one and I want to say, well, how do I know that I've seen this here? I've seen it before. Well, what I'll do is I'll add every single string that we come across to some sort of set. I'm going to use a set, and then basically when we get to this one, we will just check if this is in the set, and it'll be like, oh yeah, this was in the set when we added it over here, and then we can add that to the result because we've already seen it in the set. So we should have one. I'm going to call this one seen so far. Okay, this is a set. And then let's have a start. So you know how I said, like, for current window, right? We were going to have 0 and 10, but we're going to replace these with start and end. So start is going to be 0 and end is going to be 10. An important thing to consider here is eventually I'm going to say like string start and end, and to have that you need to have a string that is, let's see, yeah, see, the string can be 1 long. That's a problem. if the string is 1 long, that means your result should just be just an empty list. So maybe let's add that here. So we'll say if let's set n equal to length of s. Okay, and we'll say if n is less than 10, then we just return nothing. Okay, that should already cover some cases where the length is less than 10. Then what we do, I guess you could say return result, but it doesn't really make a huge difference there. Now what I'll do is I will say, so basically what we're going to do is we're going to look at this one, and since it's not already in the set, we're going to add it to the set, and then we're going to increment by 1. So we're just going to move to this one, and then we're going to add it to the set, and then we're going to move to this one, and we're going to slowly go through all the way until we are at the last, I don't know, that's not 10, but this is 10, I believe, 4, 3, and 3, yeah. So until we're here, and then we return our result once we've gone through the entire list like that. And that should have a time complexity of O of n, because we're just having a window that slides across, and we are going to hit a little less than all of the elements, but since it is of n, it's going to be O of n. So what I'll do is I'll say, we'll do a while loop, and then basically when the end goes past the length, then we can return. So we'll say while end is less than, so let's imagine we have one that's 10 long, and our end is 10, so we want it to go to when it's less than or equal to n, because otherwise it's going to miss that last substring. So now what we'll do is we'll say, okay, what we're going to do is we're going to go through the list now. So we're going to say current substring equals to s. It's going to be between the start and the end. And then we'll say if current substring in our set, so if it's in our seen so far set, then what we do is we append it to our result. Result append current substring. Okay. Now, the other option is that the substring is not in it. In that case, we have else. We want to add the substring to the set. So we have a set dot, sorry, not set, seen so far dot add current substring. Okay, so yeah, so if it's already in the set, then we add it to the result, and if it's not, we add it to the set. Okay, and then we just simply increment our start by 1 and our end by 1. That's the whole sliding window. So we start with those, and when we increment the start and the end by 1, we now have this window, and we apply the same logic. And then what we should do is we should return our result. Let's see how this works. Just to clarify, this is completely raw and unfiltered. I haven't tried this problem before, so let's see. Oh yeah, okay, so there's the duplicate problem here. Okay, how can we fix that? I could, complicate it by iterating through the result and making sure everything's the same. Or let's see, I can make the result a set, and then I can just convert it to a list at the end. This should hopefully fix the problem. Oh, we changed it to a set, but we saw the pen, which is for lists. So we changed that to add. Okay, beautiful. So hopefully this should work. So essentially, all that we do is we have, just to explain it, we have our 10 here, This is our first 10 substring, okay? And all we do is we check if it's in the set. So basically, the set is called seen so far. That completely tells you what it's for. It tells you what we've already seen, what we've seen so far. So we check this. Our set is empty right now, so it's clearly not going to be in the set. So what we're going to do is we're going to add this to the set, and then we're going to go to this one, and this one's not in the set either, so we're going to add it to the set, and then we're going to go to this one, and eventually we're going to get to this one. Sorry, no, we're going to get to this one, and we're going to be like, oh, we've seen this already. It was over here. This is in our set, so we're going to add it to our result now, okay? And it's already in the set, so we don't have to re-add it to the set. We could either way, because like the set will automatically remove that duplicate, but yeah, we really just need to add it as a result. That's all we really need to do. And then what also will happen is we have this one in our set too. As we slowly moved our sliding window, this is also in our set, and what's going to happen is we're going to see it here again, and the computer is going to be like, oh, we've already seen this. This is in our seen so far set, so we're going to add that to our result. And then eventually you get to the last 10, and then after that it simply returns the result. So hopefully this should work. Let's give this a run. Beautiful, look at that. 19 milliseconds, beating 97.1. This should be a O of n time complexity due to the fact that the sliding window just simply iterates over, and no like characters are being compared to other characters. It's just a window, and it just moves across for each iteration. Anyways, that should be it for today's video. Thank you guys so much for watching. I hope you guys found this one helpful, and let me know if you guys can find maybe a better way to solve it. I haven't tried any other ways, but this seems to be pretty good. I bet though maybe there's got to be a better way, surely. But yeah, anyways, thank you guys so much for watching, and I will see you in the next one. Bye bye.